In this video, we will learn about exception handling in Python. Exception handling is of two types, built-in type and user-defined exception. Here, we will concentrate on built-in type exception only. So, let's see what is an exception. An exception is a rarely occurring condition that requires deviation from the program's normal flow. That means we are not getting a result as expected. Exceptions are raised when the program is syntactically correct but the code resulted in an error. That means the program is in a running state but it contains some code which cannot be executed by the interpreter or compiler. When exception occurs, the Python interpreter stops the current process and passes it to calling process until it is handled. If not handled, the program will crash. Here are some common exceptions available in Python. The first one is the zero division error. When a number is divided by 0, this exception arises. Import error and import fails. That means we are importing a wrong module. Index error, a list is indexed with an out of range number. That means we are indexing a list or a tuple which does not exist. Next, name error, an unknown variable is used. Syntax error, the code can't be parsed properly. Type error, a function is called on a value of an inappropriate type. Value error, a function is called on a value of the correct type but with an inappropriate value. End of file error, in short it is called EOF error, is raised when try to read beyond the file. This EOF error has already been discussed in file handling video. There are many more exceptions available in the Python which I will discuss at the time of demonstration. Note: Python has several other built-in exceptions like OS error, etc. Third-party libraries also often define their own exceptions. Let me demonstrate some of the exceptions. Look, when 5 is divided by 0, so it arises zero division error exception and the message is division by 0. And this is the line of code from where the exception arises. The exception name and the message are provided by the interpreter. Next, if I import, say, math1, this is called module not found error, no module named math1. If I write import math, it's okay. That means math module exists. And this module not found error is a one kind of import error. Suppose we have a list like this, say 10, 20, 30. Now, the index of 10 is 0, index of 20 is 1 and index of 30 is 2. Now if I write L of 1, that's okay. Now if I write L of 5, so this 5 index does not exist within the list L. Now if I press enter, it will generate index error, list index out of range. This is the message. If I write P plus 2, so it will generate name error because P is not defined. Name P is not defined. Now if I write printf, say hello, so this is also a name error, printf is not defined. Suppose I am writing s equal to abcd, then enter. So this is syntax error because I have not closed the quotation while writing this string. So this abcd must be enclosed within a single quote or double quote. Here I have not closed the single quote. So that's why it generates a syntax error. End of line while scanning string literal. This is the message. Suppose abcd is a string and we are trying to add an integer with the string. So it will generate type error. Look, can only concatenate string not int to string. That means a string can be added up with a string only, not with a number. Suppose I have written like this, say a equal to input, say int input, enter any number. Now if I press enter, so it is asking for an integer number, and if I write abcd, so it generates a value error. Invalid literal for int with base 10, but abcd is given. So this line of code expects an integer, not a string. I have entered a string value. That's why it generates a value error, because a wrong value is entered against this line of code. Now look, all these exceptions are generated by the interpreter. So whenever the interpreter encounters this kind of exception within our program, the interpreter will stop that program, display this error message, and the control will come back to this prompt. So the question is how to handle this exception, how to control this exception from our end. And for that, the Python developers provide some methodology, keyword, and techniques to handle this exception from the user end or from the programmer's end. So next, start with catching exception. In order to handle the error raised by the statement, we can use try except statement. So by using this try except statement, we can handle these types of exceptions and display the message according to our choice. Try except is used when we think that the code might fail. Look, this is the structure of try except. The suspicious code which may arise exception must be written under the try block. And if the code under the try block arises some exception, the control will move to the except block. So run this segment of code while there is an error. So whenever the try blocks encounter some error, the control will move to the except block. If there is no error or exception within the try block, except block will not execute. So this except block will simply bypassed. Let me show you an example how to catch exception. Suppose this is the try block. After try, we have to give a colon, and by maintaining the indentation, we have to write like this. Suppose I'm writing a equal to say 10 and b equal to say 0. And next line, we are doing a divided by b. Since b is 0, so it will generate an exception. So whenever it encounters an exception, the control will move to the except block. Here it will show there is an error, and if there is no error, it will print the result. So print result equal to C. But in this case, this code will generate an exception. So from this point of line, the control will move to the except block. Then it will print there is an error. After executing except block, it will print the rest of the code within this program. Here I am writing rest of the code. This segment may contain more than one line also. So let's run the program. Look at the output. There is an error, rest of the code. Now look, if I change the value of b as 10. So in the next line, c equal to a divided by b, that's mean 10 divided by 10, it will generate a result 1. So there is no exception. So in this case, result will be printed or displayed within the screen. And this time except block will not execute. So this will be ignored and come to the rest of the code. Now look, save the file and run the program. Look, it is displayed 1.0 as a result, and the except block is ignored. Next, catching specific exceptions. A try clause can have any number of except clause to handle different exception. However, only one will be executed in case an exception occurs. We can specify which exception an except clause should catch. Look at this diagram. Here, a single try block can have multiple except block. We can specify different exception for different except block. So according to the nature of the exception arises within the try block, the control will move to the corresponding except block. After executing that corresponding except block, the control will again move to the rest of the code or other code. Let's write a code for this. So try, within the try block, I am writing a equal to Ishan. Next, print hello plus a. Now in the next line, I am writing print 10 divided by 10. And in the first except block, suppose I am writing 0 division error. So look, 0 division error is the exception name where Z, D and E are in capital letter and rest of the character are in small letter. The beginning of each word starts with a capital letter and there will be no space in between the words. So whenever this try block encounters some 0 division error, the control will move to this except block only. So in the next line, I'm writing print division by 0 error. So this message is written by me. Now, in the next except block, here I'm writing the type error. So T is capital and E is capital over here. And this is a single unit type error. So in the next line, I'm writing print type incorrect. That's all. In this way, we can write a multiple except block within this code. And at the end, we can also write this except with no specific exception name. That means it can handle any type of exception. For zero division error, a separate except block has been written, and for the type error, a separate block has been written. And for the other exception type, this except block will handle the situation. And if you think that your code might generate these two kind of error, so you don't require this blank except block. Now let's run the program. Look at the output. Here there is no error, so none of the except block has been executed. Now suppose I'm writing a equal to 10 instead of Asian. So a string is added up with an integer value. That means there is a type error. This operation cannot be done by the Python program. Now look, it will arises a type error. Run the program again. Look at the output. So it is displaying this message, type incorrect. That means for this line, it generates a type error and the control moved to this second except block, and for that it is displaying this message, type incorrect. Now look, I am reversing the code. Now I am writing 10 divided by 0. So this time a zero division error exception will arises, and for that the control will move to the except zero division error block. Now if I run the program, hello Ishan, this is correct, so it displayed this output, hello, then plus a, that's mean Ishan. And after that, it encounters a zero division error over here, that is within the line print 10 by 0, and for that it has displayed this message, a division by 0 error. Look, a division by 0 error. Now if I write say print x, look, the x variable is not defined. I have not written anything what is the value of x, and for that it will generate name error, and I have not specified any name error except block, and not even a blank except block. Before executing the program, let me write this 0 as 10, otherwise it will generate a zero division error. So the first three lines of the try block are correct in all respect, so this three line will not arise any exception. An exception will arise for this line print x, because x is not defined. Now look, if I run the program, it generates the exception provided by the system or the interpreter, name error. Since I have not written an except block for this name error, so the control has been moved to the interpreter. So this exception has been handled by the interpreter, not by me. Now if I write except name error print variable undefined. Now this time if I run the program, so it will generate variable undefined. We can also omit this name error. Now still if I run the program, so it will generate variable undefined. So the except block with no exception name must be written at the end of all exception, because it is capable of handling all type of exception. If I write this block at the beginning of the code or the beginning of the exception series, suppose I am writing over here, so this except block can handle all types of exception, and that's why we do not require the following exception block. Now if I run this code, you will get an error, default except must be the last. So this is called the default except. Since this except block handles all types of exceptions, so there is no need to write other exception after that. So default except block must be written at the end of all exception or all except block. Now declaring multiple exception in a single except block. Look at this code or the structure. So here is the try block, and for that I have written a single except block, and this except block is capable of handling multiple specific exception, and these multiple specific exceptions are written within a parenthesis and are separated by comma, and for these three exceptions we may write a common message and then the other code. Let me show you an example. Let me use this previously written code. Suppose here in the last except block I am writing say name error, first of all I have to use a first bracket, then name error comma IO error comma syntax error value error. So these are some exceptions written within the same except block. and here I am writing a common message, error found. So zero division error will be handled within the first except block, type error will be handled in the second except block, and name, IO, syntax and value error will be handled in the third except block. Now if I run the program, look at the output, print x. For that it arises an exception because x is not defined, and x generates a name error, and name error is written within this except block, and for that it is showing error found. So in this way we can declare multiple specific exceptions within a single except block. Next, else with try except statement. Look at this structure. So here is the try block. So when the try block encounters an exception, the control will move to the except block, and if there is an exception, else will not execute. This else block will not execute. And if there is no exception within my code or within the try block, at that time only else block will execute. And for that I have written this code. Under else I have written this code execute if no except block is executed. Our code may contain more than one except block. So if none of the except block is executed, then only the else block will execute. In other words, we can say that if there is no exception, else block will execute. So let me modify this code. Suppose here I am writing else, the code is error free. That's all. Now here I am initializing x as 10. Now if I run the program, look at the output. The code is error free. Since there is no exception arises within the try block, none of the except block has been executed, and for that else block is executed. Now if I disable this line or comment the line x equal to 10, that means x is undefined. Again it will arise as an exception, that is a name error exception. So this except block will execute. Look what happened, an error found. Since an except block is executed, for that else is not executed. So this time else is not executed. Note, the statement that don't throw the exception should be placed inside the else block. That means we can place those lines of code under the else statement which do not throw any exception. Next, try finally block. Look at the structure. Along with try and except, there is another block named as finally. This code will always be executed. That means whether there is an exception or not, that doesn't matter. Finally will execute every time. Let me demonstrate this finally by writing a code. Look, here is my previous code. I am writing over here finally, F-I-N-A-L-L-Y, finally. The code will run, or we can say this code will run no matter what. Now look, my code contains an exception, that is print x. X is not defined. Here we don't require this else part. Let me remove it. Now if I run the program, look what happens. Error found has been displayed in the output screen, and after that this code will run no matter what. This has been printed in the prompt. Now let me remove this comment before x, so x equal to 10, and for that there are no more exceptions within the try block. Let me save and run the program again. Look, this time also it is displaying the same message, the code will run no matter what under the finally block, and this time there are no exceptions. Generally the code like closing a file is written under the finally statement or within the finally block. The except statement using an exception variable. Exception variable is used by using the as keyword. The object will return the cause of the exception. That means this object will store exception related information. Look, after zero division error I am writing as E, and after my message a division by 0, let's print E. So E is the object of zero division exception, and whenever we print this E variable, it will display a system generated message which are related to zero division error. Before that, let me create a zero division error. So in this line print 10 by 10, I am writing 10 divided by 0. So for that it will generate a zero division error, so the control will move to the zero division error, and then we will get the desired output, That means it will display a zero division error along with the value of E. Look what happened. Along with my message, a zero division error has been displayed. Look, a zero division error. And in the next line, I print the variable E, and for that it is showing division by 0. So this message is generated by the interpreter and is stored within the variable E. This is an object of zero division error. And obviously, finally, block will execute. Raising exceptions. An exception can be raised forcefully by using the raise clause. It is useful in that scenario where we need to raise an exception to stop the execution of the program. That's mean we intentionally stop the execution of a program by raising an exception. So let's write a code. Let's delete all this line of code. Let me take num equal to or n equal to say input, enter any number. Next, if int of this number is less than 0, so it raise an exception, say value error, and the message of the value error is negative. Suppose you don't require a negative input, and for that I raises an exception which is called the value error. That means the desired value is not entered, and for that here is the message negative value. And in the else part, print value accepted. Now let's run the program. So here it is asking enter any positive value. Suppose I am writing -10. So it raises a value error and the message is negative value. So whenever we are writing this raise statement and raising an exception, the control will move to the interpreter. And on behalf of me, interpreter will raise the exception and it will display a system generated message. And along with the system generated message, it will show my message in the error message. Look, here I have written negative value, so it is displaying negative value in the error message. Now if I give a positive value, say I'm writing 7, value accepted. So we can raise any exception we want. Note, we can re-raise an exception. That's mean, let me delete this line, delete all this line. Suppose I'm writing try, and within the try block I'm writing n equal to 5 divided by 0. That's mean it will generate a zero division error, and the control will move to the corresponding except block. Suppose I've written only a default except block, that is a except block with no specific exception name, and here I have written print an error occurred, and after this print statement I have written raise and nothing else. Now look, if I run the code, look at the output. So when the code encounters zero division error, the control goes to the except block and it has displayed an error occurred. Look, an error occurred. And after that we have raised an exception by using the keyword raise, and the interpreter displayed its own message. That's mean the file name, the line where the exception occurs, the line, and this is the exception name and the exception message. So this is generated by the system or the interpreter. So this is all for this video. You can use all this type of exception in your code. Still, if you have any problem, write down in the comment box. I will try to reply you back as soon as possible. Thank you.